Hello YouTube and welcome back to another video. In the last one we went over the components, mostly the code and what you can do with code in LaTeX and what you can do with LaTeX. Then we went into Bezier curves and splines, followed by the different path nodes and custom components, which was a very fancy button that took everything that we learned so far and put it together into more of an advanced kind of topic. In this video, we're going to move from components over to advanced. We're almost done. The light's at the end of the tunnel. And so the first thing for advanced is custom fonts. So we have our source folder, we have scenes, and then we have motion canvas D, TS, our project files. Then there's a global.css file that we can then add. And we can import font families. Then it looks like in the project TS file, we want to import global.css. We want to do global.css. And then we can have our font family saying font family equals free of code, because that's the font family there. Okay. Loading fonts from a local file. So we have root public fonts and then the TTF file. So if you there is a type of font that's just images. That could be one option that we could then do. If you don't know what I'm talking about, there's this thing called Font Awesome. You can have all these different symbols. There's icons. So these are all different fonts that we could use. So if I could go to BOM. And then there's also other ones as well. So now we have multiple different fonts. Cool. Project variables. I think we really talked about project variables already, but making animations dynamic can be achieved using project variables. They could be used for dark, light themes, changing node styles, etc., etc. So we have a motion player canvas, source, variable, and then we can also just go circle fill red, and then we get that variable by doing use scene variables get circle fill. And then why does it say blue? I would expect it, if it's get, it would it seems like a setter. Use scene. Produce a scene. Variables. Get. Okay. So it's a default. I wish the guide would have told us that. because normally I'm used to that being like variable and then what the value is going to be. So in this case, it is using variables. Which variable do we want? We want to get the circle fill variable, which is red. If that variable is not filled in, we'll use the default of blue. But in this case, circle fill will be the value of red because that is already there. So yeah, I would much like to use it in make project or in project.ts like this instead of doing like a component style. Random values. So it looks like they use random values here, and we have use random next integer, more like a Java syntax, from 0 to 1 or 0 to 10. There's a random API, random return based on this logic. Wait, that was it? Pseudo-random. So it's z equals x plus x is undefined, but x plus equals this address space. I don't know, see that well. And now we're doing bit operations, bit manipulations, and then we're going to generate a value for it. So this, I think, sets z to be a new value. And then we take x and we add the same value to it again to get another bit of information, and it creates a random value. Interesting. Okay. Unlike math random, use random is completely reproducible. Each time the animation is played, the generated values will be exactly the same. So this is why it's pseudo-random. The seed used to generate these numbers is stored in a meta file of each seed. You can also provide your own seed to find the sequence of numbers that best suits your needs. So if I go to scene, first scene, so this seed looks like it's for the random value. So if I delete my meta file, it will create a new seed. So yeah, interesting. That's what that seed's for. We can also just use our own seed if we needed to. The animation at the top of this page uses a random number generator to vary the height of rectangles and makes them look like a sound wave. Yeah, it does. So here we have our 40 rectangles. And then we have a sequence, we have a loop. We're going through all the different rectangles. Random next integer from 100 to 200. That will be the size of y. And then we're going to go back to 10. And then we are changing the color. Yeah, cool. So that's the random value section. Filters and events or effects. So a filter lets us apply various effects to the nodes. And you can find all available filters on MDN. Blur, brightness, contrast, grayscale, hue, rotate, invert. Okay. So, that's blur. grayscale, hue, contrast, blur. Okay. Let's look at the code for this. So we have filters, all time pass. Time pass is time pass is a signal. Time pass, is it being used anywhere? It's just a signal. Only I would expect it to be elsewhere. Let's see. Icon reference. Icon reference is located there for the image. Current effect is this value here. So current effect is set there. Icon ref dot filters blur. Okay. Time passed. I don't see where we're using time pass except for updating it. I don't understand. Maybe it's not supposed to be visible. I don't know. I know that this right here is to cycle through everything. Yeah, I don't know what time pass is trying to do. Every node has a filter property containing an array of filters. This can be applied to the node. You can declare this array yourself or use the filters property to configure individual filters. Both ways are shown in the example below. Okay. Filter properties, filters array. So we have our image, and we're going blur and not blurry. Makes sense. Blur signal. Blur signal. Yeah, that makes sense. And if we go to property, there's our image. We have filters dot blur. Okay, and if we go to the array, oh, I see where they're putting the array. They're just changing that. Both work, up to your style. And then we can have two different components. So we have the left segment, right segment, center segment, and we're going through. And this is mapping the contrast value that we are now setting here and here. So we are setting the value to 1, it moves over to 1, moving the value to 5, moves over to 5. So it's doing a lot of the animation itself, and you're just saying here, go to this point, go to that point, and everything is interconnected, as we've seen in previous videos. Cool. Masking and composite video. Composite operations define how the things we draw source interacts with what's already on the canvas destination. Along with other things, it allows us to define complex masks. So you have a nice background that is using to show something cool. So we have our Mac OS background, value position, mask position. You can see the image, you can see the grid. They're yielding the view add. Okay. definitely recommend using these as a reference if you want to do something like this and play around with it. Then we have the bottom of what's actually going on. Some sort of caching. And then we have all the different animations that we need to do to make that possible. So mask position. Up here is a signal with a vector. Cool. And then the final result of all of that fun stuff is something that looks like this. So that's what's rotating things. This is what's changing the background in the back to move. So value reference is right here. This is the background image. The X is moving negative 100, waiting for 0.5, and then we're moving the X to 100, waiting, repeating. Actually, it doesn't repeat. The video just repeats. Then cached nodes. Both filters and composite operations require a cached node. Filters can set it automatically, while composite operations require you to set it explicitly to an ancestor node. And the cache property doesn't have any sort of description. It caches information. It doesn't make much sense to me why it's needed. It's just needed. Okay, shaders. This is an experimental feature. And shaders allow you to modify the look and feel of things. I do not know what a GLSL file is. OpenGL shading language. Oh boy. It's that kind of shader. So this shader file looks like this, which kind of looks like C code. So out color is this texture. Okay. I don't see people really using this, but if you need to do some more advanced shading or graphically intense stuff, the option's there. Default uniforms, source and destination, custom uniforms. Now you can do vector 2, my color, all that fun stuff. Oh, and if you're used to TypeScript, this is what the value actually is called in GLSL. That's a nice graph or chart. And we go back to caching. There's even view caching. So yeah, if you want to learn more about shaders or want to take a closer look, I'd recommend going to motioncanvas.io docs shaders. See if it's useful for you. Next is spawners. Again, it's going to be changing. Sometimes we want children's of a given node to be reactive. In other words, we want them to change according to some external state. We're kind of already doing that with other things that we've learned. But yeah, so this would be an example of one that we've already seen, I believe, where you have a signal of 10, you're changing the size. You're adding the size, and you're changing the count between 3, 2 linear, wait 1, back 2. So, cool. And you can create a pool. To increase performance. So you don't have to regenerate and deactivate everything. You just have a pool of objects that just become visible or not visible. And then you can also spawn them again. Then we have experimental features. Motion Canvas uses the Semver versioning schema. So if you don't know what Semver is, it is major, minor, patch. Major is incompatible API changes. Minor is functionality that is backwards compatible. And patches are typically bug patches. So animations using 3.2.0 will work just fine for 3.2.1, 3.3.0, 3.4.0, and so on, because they're made to be backwards compatible. Things should not break. Experimental features don't follow this rule. They are subject to change at any time and may break your animations. They are meant to be used for testing and feedback purposes only. To turn on experimental features, make project in your project.ts file. You can turn them on. Next, we have authoring plugins. And this will be the last advanced section topic. Okay, so authoring plugins. Plugins are a way to extend the functionality of Motion Canvas. Motion Canvas consists of two parts running in separate environments: a Vite development server running on Node.js and an editor running in the browser. So this is what is used to create Motion Canvas. And there's all these different sites are doing that. If you wanted to modify Motion Canvas, you can learn this this formatting. I will not be going through this, but all sorts of things you can do with this. The runtime of all logic necessary to play animations, such as player instance, scene definitions, including the actual source code of your animations, etc. And then we have an editor, the interface that lets you preview your animations, edit the settings, etc. Depending on your needs, you can extend any of these parts with a plugin. And then we're going to go deeper into those three different components. And then we have a plugin example. You can take a look at our FFmpeg plugin for example of a fully fledged plugin. This runtime portion provides the editor with a video explorer that sends the rendered frames over to Node.js. The server portion uses FFmpeg to convert the frames into a video. So it's sending the front end logic to the backend, or sending a request to the backend to parse the scene information, and kind of like running React on the server, similar to like what Next.js does. If we look at our project.ts, no, it's vite.config, that right there is a plugin. Motion Canvas technically is just a plugin on Vite. And then FFmpeg is also just technically a plugin on Vite. So you could, if you didn't like Motion Canvas and you wanted to have a very similar style of doing things, then you can just replace that with something else. Cool. So we're going to go into Runtime. Runtime allows you to extend the runtime components like a scene or a player. Let's start creating the entry point. A simple file that exports our plugin for now, we'll put that file in our source directory. So we have a plugin.ts. And actually, let's clean this up a little bit and I will follow along. Let's make a plugin together. Okay. So it wants me to, in the scenes, outside of scenes, it wants me to do a plugin.ts. Okay, in plugin.ts, we're going to put this information. In the example, we subscribe to the onRecalculated event to play an animation from the beginning whenever this event occurs. Recalculating happens when we edit the animation either in the editor or the code. Now we can import the plugin in our project file. Note, make plugin returns a function that we need to call to create the actual plugin object. This can come in handy when developing a Node.js plugin. Plugin node. Yeah, we'll get to that. So we have plugin. And then we have plugins. My plugin. So it's an array of our actual plugins, and then we have to call the function. Okay, and that's it. You can run the project and see your plugin in action. Check the plugin interface for a full list of available hooks. Okay, so we got setters, render, project, presenter, player. Player is the instance right after it gets initiated. So it's not like an NPC player, it's like the video player. And then we have exporters. So our plugin let's actually change what we had for our first scene to not what's this plugin supposed to do again? onRecalculated, to play the event, to play the animation from the beginning whenever this event occurs. Oh. Kind of a good example of a plugin, but because we're doing this in dev mode, it already does that kind of under the scene. But it's still cool. Then we have editor plugins. They're an extension of real-time plugins, which we just talked about. It includes additional hooks for extending the editor interface itself. This is an experimental feature, so be careful. We have make editor plugin, function imported from Motion Canvas UI to define it. This gives us access to some additional hooks that we can use to extend the interface. In the example above, we use tabs to declare an array of custom tabs that will be added to the left sidebar. The tab configuration is imported from a new file called custom tag config tsx. that is yet to be created. Let's take a look at how this looks. Okay, so we have our plugin. We have a tab component, our pane component, use tabs to declare an array of custom tabs. Oh, talking about these custom tabs. So we have our photo camera separator, hello world. So by doing this, I would expect to actually have a custom tag. So let's try this. And this custom tab should just create a hello world. Yes, it does. You have to redo the whole thing. Okay. RGB. Okay. So here's our custom tab object, which is just a camera. So if we look at our plugin, this is our tab object itself, my tab, custom tab. We have a photo camera is what we wanted to display. And then we can have the pane itself, which is this image, title of my pane, ID is custom tab to match that ID, separator is of 1, we can do hello world, and then we have to export it, so name is inspector. So if I settings, console, my tab, so that must be where this title comes from. Tab component, pane component, and that's how you make a custom tab. Cool. First of all, the editor is built on top of P-React. All these different things. Fast 3 kilobyte alternative to React with the same modern API. It doesn't really use React, it uses P-React. What? React. So it might be a variation of React that still does React type things. Okay. This means that JS files are extended in the editor. We need to let TypeScript know that it should import JSX factory function from the P-React and not from Motion Canvas 2D. Okay. So all those people that said that you used React to program things were wrong. It's P-React, which is a variation of React. This is what you get when you get more advanced and in-depth. Next, we define a component for the tab itself. This component will be rendered in the navigation bar to the left, which we saw. And then it is from photo cameras from the UI to stay consistent with the rest of the editor. We also borrow the camera icon and put it inside. Similarly, we can define a component for the plane that will be rendered when the tab is selected. Lastly, we export the configuration object. Editor plugins are still fundamental and the API is not yet properly documented, but if you want to play around with some other editor hooks, you can look at this plugin, editor plugin provided by Motion Canvas. It's responsible for displaying the inspector tab and drawing an overlay on top of the preview and clicking the different nodes. So there is this one. So we are looking for tab component, which doesn't exist here. Okay. Next, we have Node.js plugins. Node.js or Motion Canvas is built on top of the Vite plugin system. To create a plugin that runs on Node.js, you need to create a Vite plugin and import it into your Vite configs TS. On top of that, Motion Canvas Vite plugin provides a symbol that lets you define Motion Canvas specific options. Let's get started by making a file for our plugin in the root directory, and let's take a look at what our plugin does. It just says hello for my plugin. So on the root level, okay, and then in TS config, we have my plugin. And since we define the entry point to the Node.js plugin, we no longer need to import the Runtime plugin in our project file. So this plugin can go away. This can go away. Which I believe that plugin was my editor plugin. We might be able to have both. We'll see. Notice we can define the entry point as plugin TS because it's a relative path and it resolved blah blah blah. And then we can pass options to the runtime plugin. Okay. Entry point plugin.ts. Oh. Okay. So what this is saying that because we did this as a Node.js plugin, we no longer need to have plugin set up in here. We'll still use it though. And then for an entry point, it will be this file because it's relative to this file. Okay. So if I would stop this and rerun, let's see what happens. You're getting an error. Okay, so we need the experimental feature flag in order to run anything. Oh, we got a little experimental option that just turned on. Yep. And there's my hello world from before. Cool. So it still works. This right here, hello from my plugin. Is it here somewhere? No? Nope. Okay. There's the hello for my plugin. So it creates kind of like a web server, almost. So that could be useful if you needed some to make backend HTTP calls. So in this case, if I'm making modifications here, it would send a post request or a put request to the backend. It would get captured here, and then maybe return back different results. Pretty cool. Oh, I could have just read down here and it would have told me how to access the plugin. This is what I get for not reading properly. Then we got my V plugin. Then we can do plugin options. So instead of just the entry point, we can do runtime config. So if we have a runtime config, I hate bugs, is not assignable to type, is missing. Okay, well, you should be able to do runtime configs. It's just not working properly. You can then update the runtime plugin to receive these options. So options foo. Okay, so runtime config. Then you go into plugin.ts. You incorporate your runtime config, my plugin options, options foo, and now you can interact with it. Actually, let me see if I can just fully commit to it. What actually happens. And then you go to plugin.ts. Default. Ugh. I want to take this stuff, copy. I'm going to take this. Paste it here. I like my plugin that I did there. Does this go away? No. Okay. Well, I tried. It is not assignable to type blah blah blah. Yeah. It's looking for a promise. So technically, no. Yeah. Looking for a promise in order to send over the runtime config. Async. Yeah. I'm not going to play around with it too much. Oh no. Edit, redo. There it goes. It was worth a try though. And with that failed attempt, we conclude our advanced section of Motion Canvas. This is basically all there really was for learning Motion Canvas. You now have everything that you need in order to make fun and cool and fancy animations. In the next section, we're going to go over the different parts of the documents that we haven't seen yet or haven't gone through yet. Next one will be the API section, followed by a blog section. The API is not a HTTP or REST API type thing. It's like a SDK, software development kit type API. So we're going to look into that in the next video, followed by video 21 being about blogs. If you do care about APIs and want to make API calls and that sounds cool, then video 22 will be about that, and we're going to be putting it all together with the video that follows. So thank you all for following me on this journey of learning Motion Canvas. After this series, there's going to be some really good things coming down the line, so I'm excited for that. Hopefully you are too. If you're enjoying this content and wants to see this channel grow and get more mature, then hit the like button, hit subscribe, and I will see you in the next video. Until then, see ya.